today. Oh, also, someone on B-Day left this bag on Thursday. I think it was from my second period class, or the next one. But that's not okay. So I'll just keep asking my classes till we find someone. All right. So yeah. I feel like I missed something. Apparently not. Okay, so the concentration of a solution is how much sample is dissolved. So if it's concentrated, there's lots of sample in your solution. If it's dilute, there's not much sample. So hopefully these words you've heard these before. So we measure concentration a few different ways. We can do something called molarity, which we will talk about, or we can do like grams per liter. That's called a mass concentration. So Alex is going to ask you for a lot of different units in this chapter. So make sure that you are comfortable giving lots of different units, and we'll practice in a minute. So solutions in chemistry are really important. Generally, chemists make solutions. They dissolve something in a solvent, and then they mix them together, and that's what reacts. And you have done that already. You've had solutions, and you've mixed them together and seen chemical reactions. We saw the iodine clock reaction that turned blue. We've seen you had a solution. I'm trying to think of some other ones you did. And you just see if there's a color change, see if something forms. So all of those things that you have done already are with solutions. Okay, so these are the parts of a solution. I think this might be a review. So we have solute is the thing that is dissolved. So I like to think of that as like salt. When I make salt water, the salt is the solute. The solvent is the substance that is dissolving. So usually we're thinking of a liquid. So the solvent in this example is water. And then the end mixture that's what we call the solution. So we just need to make sure that we are all on the same page. But I do think that these are probably our review. All right, and then we use lots of different units to figure out how much solute is in the solution, how concentrated it is. So that's most of what this chapter is. Maybe not most, but that's part of this chapter is figuring out, well, how much is in this solution, how much solute. Okay, so this is one way. This is probably the most common way chemists use for measuring how concentrated the solute is. So we use molarity, and I think we've brought this up once. So watch out. Make sure that if you are using this big M, this big M means molarity, okay? So sometimes I see students trying to use this for moles, or I see students using MOL for molarity. MOL is for moles. Capital M is for molarity. Okay, so don't get those crossed. Make sure you keep those straight. Molarity is moles of the solute over liters of the total solution. Okay, so the units of molarity, we can either put big M or moles per liter. Those mean the same thing. So this is molarity. Alex will also use mass concentration, so that's like grams per liter. All right, so here are some other units. I wouldn't write these down, just like they're going to come up on your Alex homework, so watch out. So we've got moles per liter, millimoles per milliliter. On the second one, the milli will cancel, and so it's basically the same thing as moles per liter. Sometimes they just like it as millimoles per milliliter. The third one is grams per liter. We can do grams per milliliter, micromoles per liter, millimoles per liter. So there's lots of different units that we can use to report concentration. So this is one of the topics in ALEKS, is you have to make sure that you are using the correct units, you're reporting the correct units. So this is another conversion problem. Okay, we've had joules to calories, we've done like liters to milliliters. This is just another conversion problem. So let's go ahead and do this one together, and then I have one for you to practice. So this one says I have 0.288 moles of sodium hydroxide in 1,500 milliliters of solution. What is the concentration in millimoles per liter? My pen is on, good. So this is telling me the equation that I need to use. I need to find millimoles, and I need to divide by liters, okay? So none of these numbers are in the correct units. So I need to take this, I need to get it to millimoles. So how do I take, this is in moles, how do I get this to millimoles? Which direction should I move the decimal? To the right? Do we agree with that? 1, 2, 3. So this would be 200, oops. 288. My pen just decided to turn on. 288 millimoles. Okay, do we agree with that? Okay, and that makes sense because this is a smaller unit. So we need a bigger number of a smaller unit to represent a bigger number with a smaller, or a bigger unit with a smaller number. Okay, so we have this one, we have millimoles, that's our top numbers. Now we need liters. We have 1,500 milliliters, or 1,500 milliliters. How do we get that to become liters? How many liters is that? So we're gonna do the opposite. We'll divide by 1,000, and so we're gonna move our decimal 3 times. 1, 2, 3. Divide by 1,000. 3 times to the left, so that's 1.5 liters. Okay, so then we have a small number with a big unit equals a big number with a small unit. That makes sense. Okay, so now we're gonna do millimoles divided by liters. Okay, then we get that number, and our units are millimoles per liter. So we just need that number. I think 19.2, and I like you have this has 3 sig figs, this has 4, so you're going with 3 sig figs, so that's perfect. Okay, so this is the same as all the other chapters. Most of the questions are not going to tell you how many sig figs, so make sure you're practicing. So on the test, homework will tell you how many sig figs. Make sure on the test you practice. This should have 3 sig figs. Okay. All right, very good. Let's go to the next one. So I would like you to try this one. This one's not too bad. Let's try this one. That one's too easy. Try this one. The first is so we have 1.5 micromoles of sodium. I don't know. I like that. I think it's. If I was guessing, I would say sodium phosphide. Disodium phosphate. It's that.
So did you consider that all? Or do you just oh, we have their times? I go small. So you got change it. So when you do negative, you yeah. So it wouldn't be you're the one.
I can still see people working, so I'll give you another minute. Okay, are you ready? Okay, let's start with the number. What did you get? How many millimoles per liter? Does anyone want to share your number with us? What did you get? 300? Okay, I don't know the number, so. Okay, so then let's go back through. How do we get millimoles from this? This is micromoles. Okay, divide by 1,000. Do we agree with that? So this is the tricky part, is deciding. This is for me. For me, it's deciding. So we're going from a small number to a bigger unit. So dividing is right. So we're going to divide. 1, 2, 3. Because, oops, my pen tool turned off. Okay, so these are 1,000 apart, micro to milli. This is the bigger unit, so we need a smaller number to go with the bigger unit. We need a bigger number to go with the smaller unit. So they equal. All right, so now we have millimoles, and then we need this in liters. How do we get this back to liters? I don't know why my pen just decides to turn off. Go back. Divide by 1,000. So this is the same as 5 liters. 1, 2, 3. Okay, so we have millimoles, and again, this is telling us what to do. We need to find millimoles, and we need to divide it by liters. So we have millimoles, we need to divide it by liters. We have liters now. Okay, and that's what you got, 300? Oh, no. That's fine. So what did you get now? 0.0003. 0.0003. Okay, and then let's look at sig fig. So this one has 4. This one has 3. So we need 3 sig figs. So how can we get 3 sig figs here? Good. Add 2 more zeros. 2. Now we have, these don't count. We have 3 sig figs. Okay. So this is one of the questions on the homework. This will be on the test too, this type of question. So just make sure, what I do is I just follow this, the units, follow the units, divide the units, make sure I have the right sig figs. Okay, this is another topic. If you have this equation. The pen, I don't know why this pen keeps turning out. I don't want to do something else. We have molarity is moles per liter. So this question says I have 500 milliliters of 1 molar cobalt nitrate. How many moles of cobalt nitrate do I have? So as long as I have 2 of these, this is an algebra problem. As long as I have 2 of these, I can find the third one. Then I just solve. Okay. So this one I'm looking for moles. I don't know moles. How many moles? So this is just, oops. This is making me very annoying that I can't get this. Now we're on the wrong page. Okay. So we have 1 molar. That's the concentration that we have here. And we don't know moles, so that's going to be my X. And then how many liters do we have? We need to put that in liters. This equation is 4 liters. Good. So move the decimal 1, 2, 3. 0.5 liters. Okay, how do I get X? Good, multiply. So I have X divided by this. I'm going to undo that divide. I'm going to multiply both sides by 0.5 liters. So 0.5 liters cancels out on this side. Simplifies to 1, so now we have just X on this side. And then we have 0.5 liters times 1 molar. But we can replace this unit. Let's erase it. Instead of writing molarity, we can write moles per liter. Molarity is moles per liter. So we have 1 mole per liter. So now liters cancels out. We have liter on the bottom, liter on the top. They have 0.5 times 1. So that's this one, right? X is, or just 0.5. 0.5 moles. Okay. So that's just an algebra problem. Okay, I'm seeing some concentrated faces. Are we okay? Question? Doing okay? Okay. Okay. Yes, oops.
Okay, just with sig figs.
Oh yeah,
always,
this one is.
It's always the number with the least amount, right?
Yes. Yep, good. This one is ambiguous because there's no decimal places. So this is a bad question on my part, but yes. Oh, as long as we're doing division. If we're doing addition and subtraction, we just keep the least number of decimal places. Okay. Do you guys want to try one of these, or do you want to do a different? Do you want to do this one on Alex? Try it. Okay. All right. Go ahead and try this one. So we're looking for the volume.
I saw that. That was rough. That's so funny. That's right. I was doing that since that. The burgers were bad. It was the mountain climbing, bro. A lot of today. Because I'm just doing the plank and then they show so all I think I made it up a little bit. Yeah, but I also like one. No, it was 3.3. 3. equation.
All right, what did you guys get for this? What's the final volume? Did you have enough time? 0.3, and that should be, our units will be liters. Okay, do you agree with that? That's what you got? Should we double check? Okay, so we have this equation, we're using this equation, molarity is moles per liter. So what goes on this side? What do we have here? Okay. And what's up here? Okay, and how many do you have? 2, okay. And what should we put on the bottom? X, we don't know that. Okay, good. I'm gonna also bring the units along. This is moles. This one's molarity. Okay, how do we solve this? There's an X on the bottom. This is kind of tricky. It's our algebra problem. What are we gonna do? So if we times, let's try that. So what happens if we times by 0.6? So this becomes 0.36. This becomes 2 times 6. Is that 1.2? Oh, we still have X on the bottom. So we're gonna divide by 0.6. Okay, divide by 0.6. Oops, that's the eraser stuff. Divide by 0.6. Divide by 0.6. Okay, and then what do you have on this side? So this simplifies to 1. And what's 2 divided by 0.6? 3.3 repeating. Okay, and we have X on the bottom. So then what do we need to do with that X? We need to get by itself. So that we can multiply by the X. So X will simplify to 1. Now we just have X on this side. X is 3.333. So these both have 1, so we would say like 3 liters. X is about 3 liters. Or why did I put more?
Chapter 8, what stays?
Okay. All right. Okay. Questions on that one? That one's the trickiest one. Yep.
So you start off the picture by doing like multiply X on both sides and
Yep. Yeah. Because multiplication and division are, the order doesn't matter. Yeah. The other way you could do this is you could just flip this upside down. You could do the inverse. So we could flip this upside down. 0 over 0.6 equals X over 2. And then multiply by 2 on both sides. Ugh. Oh, sorry. Okay, multiply by 2 on both sides. And then we get the same number. So that's another way to just flip. So the X is on the bottom. Okay. All right, let's keep going. This is the last equation we're going to talk about today. This is the dilution equation. This will also show up when we're doing titrations. When we do lab 13, this happens. This is the equation that we're using. So we have M1V1 equals M2V2. This also shows up as C1V1 equals C2V2. So depending on who you're learning this from, this might show up as a different equation. So we're talking about the molarity times the volume. These are molarity 1 times volume 1 equals molarity 2 times the volume 2. So if you can figure out which molarity you're starting with, which volume you're starting with, you can figure out either the molarity that you want to end up with or the volume that you need to start with for the end. And then this picture represents what's happening. So if we start with something really concentrated, we can calculate how to make this solution or the solution or the solution. This is called a serial dilution. We diluted it over how many times? 1, 2, 4 times. And these aren't too bad. And as long as the units are matching, then we don't have to change, we don't have to do any unit changes. Okay, we've got this one. Looks like we've got it. Okay, here we go. Here, let's try this one. This says, a chemist needs to dilute concentrated sulfuric acid to 1 molar. The chemist needs 100 milliliters of the solution. Concentrated sulfuric acid is 18 molar. What volume of concentrated sulfuric acid should the chemist measure? So this is like a real world problem. This is, I've done this for our labs. Usually the labs need 6 molar hydrochloric acid. Hydrochloric acid comes as 12 molar, so I have to figure out if I need 100 milliliters for both of the classes. How much do I need to pull out of the concentrated bottle to dilute to get 100 milliliters of this? Okay, this is like chemists do this every day, and I've done this for this class. Okay, so we need to figure out. We have M1, V1, M2, V2. So what do we have? Reading this problem. What do we have? What about the first number? It says the chemist needs to dilute concentrated sulfuric acid to 1 molar. Where should we put that? M1? Okay, let's put it at M1. And then we have the chemist needs 100 milliliters of 1 molar. So where should we put that? So this one is a volume. So it's what we start with too. Where are we? Pen turn. This is a volume, so this is going to be the same. They need to go together. So if you're going to call this M1, this needs to be V1. Does that make sense? Because they go together. I don't know why this just decides to turn off. Okay. Concentrated sulfuric acid is 18 molar. So where does that go? M2. Good. And we don't know V2, so I'm going to write that down. Okay, so then we are going to write what we know in our equation. So we have 1 molar is M1, 100 milliliters is V1, and that is proportional to M2, which is 18 molar, times V2, which is, we don't know. That's what we're looking for. Okay, so we're looking for V2. How are we going to solve for V2?
Get it along.
Get it by itself. Good. These are multiplied. Good. So if we divide by 18 molar on both sides, so 18 molar cancels out, simplifies to 1. We have volume 2 is this. And then we can also look at our units. Molarity on the top, molarity on the bottom. And then we end up with milliliters. So 100 divided by 18, what did you get? 5.55. Okay. Let's round to 5.6. This one is also a problem. I haven't given you any sig figs. So this one I will work on going back through and fixing my sig figs. Okay, so 5.6 milliliters. So first we would measure out 5.6 milliliters of this 18 molar solution. We would dilute it to 100 milliliters, and then we would end up with 1 molar of the sulfuric acid. Okay, so watch this pattern. So these two go together. So if they go together, you're going to multiply them together. It's right here. That's what you're doing. This is the pattern. If they go together, multiply them together. This is the odd number out, so you divide by that number. So these are pretty straightforward. If you can figure out, this is talking about the same solution. This is talking about a different solution. Multiply the numbers that go together, divide by the thing that doesn't go together. Different solution. Does that make sense? Okay. And then these are pretty straightforward. Just match the numbers, multiply, find the other one, divide. Okay, go ahead and try this one. think this is our last thing we're expected to do.
I don't want to share with you. I don't. It's not really. But you can. I can get the right answer. No, wait. I see. I can be any existence. I got you.
All right, we're sharing some answers. Okay. What did you get? What are we looking for? Let's first. What are we looking for? So we're looking for a volume, V1 or V2, depending on which one you label it. Either is fine. Okay, so we're looking for a volume. What did you find as the volume? 100? 500? 500 milliliters. Okay, and you even put the units. Very good. Okay, so let's do the math, the pattern. So, currently the solution is at 0.1 and is at 500 milliliters. So these two go together. They're talking about the same solution. So if we multiply those together, and then we divide by this odd one out, this one is talking about a different solution. So this is one solution. We'll just call it solution A. This is like solution B. So multiply these together, divide by 0.5. Is that how you got 500? Okay, I got 100.
Oh, that's what I hit.
You got 100 too?
Yeah, I was
Okay.
saying it's 500.
Oh, you're saying that maybe V1 or V2 is 500.
Yeah.
Oh, okay. You were labeling. Okay, so the answer, the final volume, V2 is 100 milliliters. Or for solution B, that would be 100. Okay. So we could also set this up as this is what we're starting with. So 0.1 times 500 equals, we have 0.5 molar times V2, and divide this all by 0.5 molar. So that V2 is by itself. This simplifies to 1. We have just V2 on the side. And we end up with 100 milliliters. Okay, questions? Feel pretty good about this one? Okay. All right, the rest of the time you can either work on lab 8 or pre-lab for lab 10 or Alex chapter 8. I'm going to hand you out this solubility chart. We're going to talk about this on Friday, but it's really annoying to look at this chart every time you have to do this problem. So if you get to this, there's a solubility problem. All you have to do is use this chart. If you don't write on this, you can use this on the test. If you write on it, then you'll have to use the Alex table. But if you don't write in it and bring it to the test, and again, we haven't talked about that, but if you get to that topic, you can. It's just easier to use that paper and see with the table. Are you doing okay? Okay. Is that enough?
Yeah.
Okay.
Yeah.